Hello everyone, welcome back to my channel. I'm Preeti. I'm a first semester computer science and engineering student at Shri Venkateshwara College of Engineering, Bengaluru. Today I'm back with another interesting mathematics topic, that is inverse of a square matrix by Cayley-Hamilton theorem. In this presentation, we will explore how to calculate the inverse of a square matrix using Cayley-Hamilton theorem. The table of contents are Introduction to inverse of a square matrix, the importance of inverse of a square matrix, Cayley-Hamilton theorem overview and statement, Cayley-Hamilton theorem and matrix inversion, applying Cayley-Hamilton theorem to find inverse, and one example problem, then practical applications and conclusion. Introduction to inverse of a square matrix. The inverse of a square matrix. A matrix that, when multiplied with the original matrix, results in the identity matrix. Existence of inverse. Not all square matrices have an inverse. Properties of inverse. The inverse of a matrix is unique and has the property that the product of a matrix and its inverse is the identity matrix. The importance of inverse of a square matrix. Solving linear equations. The inverse of a matrix can be used to efficiently solve system of linear equations. Computing determinants. The determinant of a matrix can be computed using the inverse matrix. Matrix transformations. The inverse of a transformation matrix can be used to reverse the transformation. Cayley-Hamilton theorem. Let's see the overview. Cayley-Hamilton theorem is a crucial tool in matrix theory. It states that every square matrix satisfies its own characteristic polynomial. And the statement is as given below. Cayley-Hamilton theorem can be stated as a square matrix, when evaluated for its characteristic polynomial, it becomes 0. Cayley-Hamilton theorem and matrix inversion. So let's explore the connection between Cayley-Hamilton theorem and matrix inversion. Applying Cayley-Hamilton theorem. Using Cayley-Hamilton theorem, the inverse of a matrix can be expressed in terms of power of the matrix itself. Simplifying matrix inversion. Cayley-Hamilton theorem provides a simplified method for finding the inverse of a matrix. Efficiency of computation. Cayley-Hamilton theorem allows for efficient computation of the inverse of a matrix. Applying Cayley-Hamilton theorem to find inverse, there are three major steps involved in this computation, and the first one is compute characteristic polynomial, and the second step is substitute matrix into polynomial, and the third step is solving for inverse. So let's see these three steps in detail. As we know, the step 1 is finding the characteristic polynomial. Determine the characteristic polynomial of the given matrix using the formula delta A minus x into I, where delta A is the determinant of matrix A and I is the identity matrix. And the step 2, substituting the matrix into the characteristic equation. Substitute the given matrix into its characteristic polynomial equation and simplify the equation. We obtain the general formula is given as a to the power n is equal to a1 into a to the power n minus 1 plus a2 into a to the power n minus 2 plus to the n term, that is a n minus 1 into a plus a n I, where a n is the given matrix. And the third step is calculating the inverse matrix. We can now use the equation obtained in step 2 to calculate the inverse of the given matrix. We simply solve for A inverse in the equation to obtain the inverse. I hope you are all clear with the three steps involved in the computation process. So let's solve one problem related to Cayley-Hamilton theorem. The given matrix is A, that is 1, 2, 5, 4. So first we have to compute the characteristic equation of A, that is determinant of A minus lambda I is equal to 0. The matrix A can be written as, that is the diagonal elements will be written as 1 minus lambda and 4 minus lambda is equal to 0. So the remaining elements, that is 2 and 5, will be written as usual. Now we have to solve this equation, that is we have to do the matrix multiplication here, which leads to 1 minus lambda and 4 minus lambda minus 5 to the 10 minus 10 is equal to 0. And we obtain the characteristic equation of A, that is lambda square minus 5 lambda minus 6 is equal to 0. According to CS theorem, we must have A square minus 5A minus 6I is equal to null matrix or 0 matrix. So A square gives us 11, 10, 25, 26, that is 2 cross 2 matrix. And if we simplify the 5A and 6I and substitute in the LHS part, which gives us the null matrix, that is 0 matrix, and it is equal to the RHS. The CS theorem is verified. Now we have to find the A inverse. So we shall post multiply equation 1, that is A square minus 5A minus 6I is equal to null matrix by A inverse, which leads to A square into A inverse minus 5 into A inverse minus 6 into I A inverse is equal to null matrix into A inverse. So we get the A inverse as 1 by 6 into A minus 5I. After substituting the value of A and I in the A inverse equation, we get the final answer as 1 by 6 minus 4, 2, 5 and minus 1. Now let's see the practical applications. The first one is data science. Inverse matrices are frequently used in data science, which involves processing large amounts of data and drawing patterns from them. And the second one is engineering. The concepts of matrix inversion are used in various areas of engineering, including electrical engineering and mechanics. And third one is finance. The inverse matrix of a coefficient matrix can be used to solve equations in portfolio management and financial modeling. Now we are at the end of the session, that is the conclusion part. So let's see the key takeaways. Cayley-Hamilton theorem is a crucial tool in matrix theory. The inverse of a square matrix can be calculated using Cayley-Hamilton theorem. Inverse matrices have numerous applications in data science, engineering and finance. And now let's recap the importance of matrix inversion. Matrix inversion plays an integral role in various fields like science, technology and finance. Understanding Cayley-Hamilton theorem can help you achieve your goals in these fields. Thank you for watching. Please do like and share the video.